Morning, y'all. It's Miss Johnson. It is Spirit Day for jerseys, so I'm wearing a jersey. Wearing a hockey jersey. That's just a fun fact. Let's get into it. So last video we talked about secant lines, getting closer and closer to the tangent line, and kind of being able to find the slope of a tangent line at a point on a graph. And then today in class, we're going to talk a little bit more about that. Hopefully that makes more sense. And then you can go back to that video and it will be a useful reference rather than like the first time you've seen something. That's my hope for all these videos. But so that brings us to like the overarching dream of the second half of this unit. The dream is that we can find the slope of any point at any function and that we can do it by having a formula, right? Being able to see like some awful function and saying, what's the slope at 33.9? And saying, I'll just plug that into the slope equation real quick and we're good. In reality, that's exactly how it works. It's amazing. Math is great. The only caveat is sometimes we get to confidently say it doesn't exist rather than being able to find anything. But being confidently, saying it doesn't exist confidently is just as good to a mathematician, at least. The more specific dream for this video, the thing I'm going to, do for you is I want to find the slope at any point of a specific function of y equals x cubed. And I'm going to do so by creating a slope equation that partners with it. The slope equation is called the derivative. We're just going to go for it. The method I'm going to use to do this, I'm going to put my face up here. My face right here. The method we're going to use is I'm going to kind of do what we usually do with just a regular function when you're like in algebra 1 or algebra 2 or whatever it is, where you're figuring out how to graph x cubed for the first time. You would just make a t-chart of all the values. You'd plug in points on a graph. You'd connect the dots, and you'd say, boom, that must be what x cubed looks like. Love it. We're going to do a similar thing, but instead of writing down the function value, we're going to write down the slope. And then we're going to graph these points as if it was their own coordinate. And then whatever equation we end up graphing with these points is going to be our derivative. Right, so we're going to say the derivative of x cubed is blah, blah, blah function. And we're hoping it's nice. We're hoping it looks familiar, and we're hoping that it follows a pattern so that it's easy to find later. Spoilers, all of those are true. Math is great. So the first thing to do is to find the slope at each of these points. All right, we've got two methods for that, right? We've got, I'm going to do two examples, right? We've got the secant approximation method, where we pick a close by point, like negative 3.0001 or something, right? And then we use our slope equation from algebra 1 to find the slope of that secant line. And then we say, this is really close to an integer. It's probably just 8 or whatever it is. And then our other method, and I'm going to go through these and actually do the math. The other method is our limit method, right? This is when we get to say, the slope at a point A is actually, you just take the limit as h approaches 0. You plug in a plus h to your function. You subtract it from when you plug in a for your function. And then the difference between those two is h. And then this part means the difference between those two is getting infinitesimally small. So we're actually getting the exact answer for this method. Let's go ahead and fill out this chart. I'm going to do the two methods to find two of the points here. And then I'm just going to fill in the rest of them, to be honest. It takes a long time. On your assignment, I'm not going to make you do 7 of them. I'm going to make you do 4 of them. So it's not going to be too long. Okay, let's do the secant approximation method first. For x equals negative 3, what we're trying to do, boom, this is going to look like your getting closer assignment. We're going to plug in negative 3. We're going to plug in something real close to negative 3, real close to negative 3. All right, so negative 3, and this is y equals x cubed. This is just our function. We plug that in, we get negative 27. Nice, that's off the top. I'm going to plug in the other one to a calculator because, good lord. 2.1 to the power of 3 is negative 27.027009. Cool. When I find the slope, I'm doing this. I'm just doing the y2 minus y1, x2 minus x1. I can plug that into a calculator. If you're doing a lot of these, what I recommend doing is going to wolframalpha.com, saying find the slope between -3, -27 and negative 3.001 and what I just say 0.27009. And it just does it for you. Bingo bongo, it's 27.009. So the slope is 27.009. This is real close to 27, right? Using the secant approximation method, I'm going to go up here and I'm going to say this is positive 27. The reason it's not my favorite method is because I did have to guess there at the end. I did have to say, it's probably getting closer to 27. It is, but once we get to more complicated formulas and more complicated equations, the guessing becomes more complicated. So I prefer, me personally, prefer the limit method. Let's do that for x equals 2. So if I do the limit method for x equals 2, I remember our slope formula, our slope at a certain point formula, right? And again, we're going to talk about this in the synchronous class today. But I'd say, okay, the slope at 2 can also be written as this. I'll go over notation one of these days. It's the limit as h approaches 0 of plugging in 2 plus h to our equation minus plugging in 2 to our equation divided by h. All right, some fast algebra time. This is equal to h cubed plus 6h squared plus 12h plus 8 minus 8 over h. I come over here. I'm going to simplify a little bit. The 8's cancel. Nice. I still have this stuff, except not even. Boom. I'm going to simplify a little more. Wouldn't it be nice if I could cancel these h's? I actually can, because I can cancel these ones as well. If you can cancel an h from every single term in the top and the bottom of your fraction, you're good. Off to the side, what that's looking like is it's pulling out an h from the top. And then what I'm actually doing is canceling these two, and that's why it happens to all of them. That's like the one more step version. So now I get h squared plus 6h plus 12. And now I just get to plug in 0, right? Now that I've simplified my stuff so that plugging in 0 doesn't get me a 0 on the denominator, I just get to plug it in and say, if I plug in a 0 here, I get a 0. If I plug in a 0 here, I get a 0. If I plug in a 0 here, I just get 12. All right, so for my super accurate limit method, I said that this is 12. Nice. So again, what you would do on your work and what you would do if you're trying to find the slope equation for any random function, you would pick some points that you care about, find the slope at those points using either your limit or your secant approximation method. Boom, I did that. Speed up. And so I found the slopes. Now I'm going to graph them. And I'm going to say, hope this function looks familiar. Right? It does. So we've got 0, 0. At 1 and -1, it's both 3. At 2 and -2, it's both 12. Boom, boom. For 3, it's like way up here, right at 27. And when I cannot draw, y'all. When I connect the dots, we should be saying, Miss Johnson, this looks pretty similar to a parabola. And it does. This is the line y equals 3x squared. Ms. Johnson, how'd you figure that out? I look at functions all day long for a living. But the way you could have figured it out is there's like this like stat plot stuff on your calculator that you can plot things and then do a linear curve or a quadratic regression curve, and you can figure out exactly what it is. If you're interested in calculator programming, oh my gosh, come to office hours. I just know so much about that. But for now, be satisfied with the fact that this is definitely the function y equals 3x squared. So now we said, okay, so, bringing it all together, we started with the function y equals x cubed, and then we said the slope at any point of y equals x cubed can be found by plugging in the point. It's not a u. Plugging in that point to this equation. And the reason we call it y prime is because we want to connect it to y, right? We want to say this is a partner to y. This is the slope equation for y. You need to know what y is to know what this is talking about. And we designate that by a prime, a little apostrophe. Let's check to see if it worked. So I didn't, for instance, do this one, this one, this one, this one, or this one on the video. Let's check them, right? If I plugged in -2 to this equation, I would get -2 squared is 4. 3 times 4 is 12. Boom. Nice, right? If I plugged in, let's plug in this one that I actually did do. -3 squared is 9. And 9 times 3 is 27. Verified. Right, it works there too. So if I said, so now a reasonable question, and this would have not been reasonable at the beginning of this task, a reasonable question for me to ask is now, what is the slope of the line y equals x cubed at the point x equals 4,193, right? That's a ridiculous thing to calculate. However, I just know that the slope, right, at 4193 is 3 times 4193 squared, which is a huge number. I shouldn't have picked as a big number, but that's fine. 4193 squared. The slope at that point is this. So our dream came true, right? Our specific dream up at the top that said, I want to be able to find the slope at any point of this function by creating a slope equation. Bada bing, right? Now I can say, I want to find the slope at pi. I want to find the slope at -3.7, whatever. I can just plug it into my slope equation. Pretty good. Your work is going to be doing a similar calculation for y equals x squared, so new function. You are going to have to find the slope at 4 points, graph those points, and see, does this function look familiar? It will. It'll be a linear function, so you'll be able to figure out what it is. Use y equals mx plus b. And then the other question I'm going to ask is to make an educated guess about 5x, y equals 5x squared. I don't want you doing the calculations over again. This, I'm interested in your thought pattern. I'm not interested that everyone gets everything right immediately. And then the next class period, we're going to make a generalized rule for all polynomials based on kind of what I did during this video and what y'all will do during the work. As always, I hope calculus is fun and not stressful. If it's not like that, reach out. And if you have any questions about math or Garfield or life, I'm in office hours just every single afternoon. Bye, y'all.